Welcome back once again. Hope you're ready. Okay, so we're going with the measure of central tendency statistics, data analytics. There's so many careers in statistics. I mean, I think this is the world of data. Okay, it's a world of statistics. A company that understands people using data, they're able to minimize risk. There's some insurance company that actually study how you drive. They put a device in your car, they collect data on how you turn, your speed, and actually derive an insurance premium on that. Or some claim give you cash back based on how you drive, because they try to understand human by using data. Okay? Maybe they're calculating your average speed per week, or monthly, or daily, we don't know. Have a conversation with people around you. How do they drive? Okay, what is their average speed per weekly or daily? Okay. Now let's come back. We looked at the estimated mean. We're still going to look at quartiles. We looked at mean, which is the average, and the two are the same, but just group data, and this is from raw data. We're going to look at median. We looked at mode. Now we'll look at median. Have you heard the term called median? What does median mean to you? Mean, median, is it the same thing? The median is actually if you take your data from the smallest to the highest. The middle number is the median. What does it mean? If I have marks and I arrange the marks in a class from the lowest mark to the highest, and the middle is 60, oh, what is the meaning of that? It implies because the middle 60, after 60, everyone got more than 60. Can be good. Depends on what you want to achieve. What are you looking at data? Okay. But I think a median in terms of marks of 60, that's really excellent. But we don't know. Maybe that half after the median are doing well and the lower are not doing well. But we don't want that, maybe. We want something consistent. Okay. Good. So how do we look at the median? So the median is the middle value of set of data once it has been ordered. Ordered meaning you order your data from the smallest to the highest, from the lowest to the highest, minimum to maximum. You don't just pick any middle number and we call that the median. That's not the median. I want you to think out there. What if the median is the same as the mean? What does that mean to you? Think about that while you're there. So, let's look at an example. Sipho hit 11 balls at a driving range. So Sipho is actually playing what? Golf. The recorded distance of his drive measured in meters are given below. So those are the distance. I mean, 85, 125, 130, 65, 100, all the way. Okay, now we want to calculate the median. We have to order our data from the smallest to the highest. Let's order that. We order data from the smallest to the highest. Now, if we order our data, what is the middle one? So from there to there and from there to there. Can we see? The middle is 85 because we've arranged our data. The smallest one is 50 there. This is our data. And the highest is 140. I see 140 there. Okay? So then the middle from we have 12, 11 data sets. So it implies I need 5 this side and I need 5 this side. And the middle one is 85, which is the median. So the median distance is 85, which is the middle dot. Now, what we're going to look at is, what if the middle is between the two numbers? How do we find a median? Because here we have 11 numbers. It's easy because 5 that side, 5 that side. In the middle, we have one number in the middle. We can point it, which is 85. What if we have 10? Where do I find middle? Because I put 5 that side, 5 that side. What is in the middle? Oh, nothing. What if I have 8 data set? What is the middle? 4, 4. What is the middle? Let's look at that. How do we find the median? So if Sipona hits 12 ball at a driving range, the recorded distance on his drives are measured in meters, are given below. Find the median distance for his drives. So firstly, we've ordered our data. This is the actual raw data. We arrange it from the smallest to the highest. So the smallest is 50 and the highest is 150. Now, where is the median? The middle is between 85 and 95. It's between 85 and 95 because you have 10 set of data. Okay. Another way to look at this is using this formula to find the position of the median. So we can find the position of the median by saying a half n plus 1. So this is the position of the median. What is n? N is what? 12. Okay, are we together? So this is a half. 12 plus 1, which is 13 over 2. So let's look at that. 1, 2, 3, 4, 5, 6. So 13 over 2 should give us 6.5. Okay. So 6.5 means position 6.5 is the position of the median. Then we count 6.5. So this is 1, 2, 3, 4, 5, 6. 6.5 is between there. Are we together? The two middle value taken the mean. So we're going to take the mean of the two value to find the median. If we do that, we get 90. How did we do this? It's 85 plus 95 divided by 2, which give us the median. Are we all together, guys? Okay. Which is the middle value if you arrange our data from the smallest to the highest value. Fantastic. Hope this makes sense. Okay. And you're enjoying this. Now we looked at estimated mean. We're going to look at quartiles. We looked at mean, and we looked at median. We looked at mode. Now we're going to look at quartiles. What are quartiles? Have you heard of quartiles before? Okay. Have you used quartiles? Let's look at what are quartiles. So quartiles are measure of dispersion around the mean, which is better measure of central tendency. Remember, central tendency clustered around the mean. What is clustered around the mean? Mean, median, and mode. Okay. So quartiles are a measure of dispersion. Dispersion is what? It's kind of your range. The highest minus the smallest one. That's the spread of the data. Okay. Think about if the highest minus the smallest, you get a bigger number. And plus, there's a huge gap between the lowest value and the highest value. That's the dispersion. So the median divides the data into two halves. The quartiles further subdivides the data into quarters. What it means, if we have set of data from there to there, this is the median. It divides the data into a half, and a half. The quartiles, it further divides the data into quarters, So it divides that into another half there and another half there, another half this side and another half that side. Okay, so it actually divides into quarters. Okay, let's look how it does that. So quartiles, we're going to look at a lower quartile. The lower quartile will be denoted by Q1. Is the median of the lower half of the data. So what it means is, if I have data set from the smallest to the highest, the middle is the median. The lower quartile is the median from the smallest to the median. Is the mean from the smallest to the middle. Is the median of half of the data set. Simple term. That's the lower quartile. Then the median, we already done that. This is the value that divides the data into halves. The upper quartile, which is Q3, is the median of the upper half value of the data. What it means? If the middle is the median, from there to there, the middle is the median. From the lowest to the median, I have lower quartile. Then from median, from half to the last value, that half, I'm getting the upper quartile, which is denoted by Q3, and this is Q1. Are we all together? Does that make sense? So another way we can look at this is that if I do my data, so we're going to have Q2 there, which is our median. We're going to have our Q1 there. We're going to have our Q3 there. So from there to there, you have 25% of data. And from there to there, you have 25% of the data. And from there to there, it's 25. Then another 25% of data, which is our quarters. Okay, let's see how do we actually find the quartiles using a raw data. Find the median and the quartiles for data below. Let's look at the data. So we have 12, 6, 4, 9, 8, 4, 9, 8, 5, 9, 8, and 10. So firstly, what we need to do is to arrange our data from the smallest to the highest value. Are we together? We have to arrange from the smallest to the highest value for us to calculate our quartiles. Let's order the data. Order from the smallest to the highest. So if we arrange our data from the smallest to the highest, we get 4. We have 4 4s. Let's see. I'm just going to verify. There's 4 and 4 there. We've arranged our data from the smallest to the highest. How many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12. So the best is to find the median first. Let's find the median. So the median is between 8 and 8, that position. Can you see that? So the median is there. So it's 8 plus 8 divided by 2, which gives us 8. Another way to find the position of the median is a half n plus 1. What is n? The total data set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 plus 1, which is 13 over 2, which is 6.5. Position 6.5 is the median. 1, 2, 3, 4, 5, 6. 6.5 is there. How do we find that? 8 plus 8 divided by 2, we get 8. That's the median. How do we find the lower quartile? The lower quartile, what are we going to do is to find the median of half of the data. What are we going to do is we're going to find the median, which is there. So the lower quartile is half. What is half? From there to there. Find the median. You can find the median. If you have a small set of data, you can arrange your data and look at it and find the median. But if you want the position of the median, you can use this. Because it's quarter of the data. Quarter, n plus 1, which is 1 over 4. What is n? N is 12 plus 1. 12 plus 1 is 13. 13 over 4, which is 3.5. Position 3.5 will find the median. So what are you going to go? 1, 2, 3. 3.5 is there. So which is 5 plus 6, which is 11, divided by 2, which is the lower quartile is 5.5. Now let's look at the upper quartile. The upper quartile, by looking, which is Q3, we get 9. You can do it if you have a small set of data by just arranging it and doing the data. But if I want the position, you can use 3 over 4, n plus 1, it will find the position of that. So we have our quartiles. I hope guys you enjoyed today, and we had a fantastic lesson on central tendency with me. And we hope to see you soon. And remember to keep working hard, and consistency must be one of your fundamentals. You'd rather be consistent every day if you want to be successful. It's not about working for 4 hours on weekend, one day. It's 20 minutes per day, every day makes a huge difference. Hope to see you soon, and bye.